Hey guys, I'm going to go and run through from Tuesday's class question 2 out of section 6.3. So it reads, waiting time in the emergency room for a random sample of 36 people selected from the emergency room wait worksheet, assuming that the records shown represent the population of emergency room visits for a month. So I just created a new tab for this question, and we can go to the emergency room wait sheet. And I created a random column right here. And what we'll want to do is select this entire column. Oh, went past it. So after we select it, this is where we do that equals ran. And then just remember the control shift enter. And then we'll want to copy everything. And then we'll paste the values. And so that way their value is not a formula anymore. And then what we can do from here is go to sort, and it just sorted for us here's all of our numbers for us. So this is what we're gonna go for as our wait time. So it asks us to select 36 samples. So there's 36. Notice down here it says 36. It will look a little different on a PC, but so there's our 36 samples. So we can copy that, and then let's go back here and we'll just paste it. We can just paste it right here. So with that, here's all of our 36 samples. We need to come up with the n of the sample, the standard deviation, and then our standard error from the mean, so our SE. So our n is obviously 36, we know that. Our standard deviation, we can go ahead and use the standard deviation for a sample, and we'll just select the data. And let's give it back some. Okay. And then we will, from here, we can calculate our standard error. So that's the formula is equal sign. We will take our standard deviation and divide it by the square root of our sample, and so that's going to give us 2.105. So that one is a little bit higher than the one that I know Erin did in her example with Alyssa. But again, it's just because it's 800 different, there's 800 plus samples. So, or sorry, 800 observations, and we just happened to pick 36, and this was just our standard error. So B, this is the one that's asking us also to use the finite population correction. So first, let's go grab our sample. So for the sake of this, I'm going to just hide these two columns because all I really care about is this information. So again, we'll do the ran, and we'll select our column to there. And then again, we'll do our ran, and then Control Shift Enter. And then after we get all those figures, we copy all those cells, and then we paste the values. And then from there, we can go to sort. And again, let's sort it. There we go. From smallest to largest. And this time it's asking us to pick out 20. So again, you can see down here, there's 20 of them. So we'll copy that out and dump it into our 6.3 tab. And we'll just go ahead and paste it. Let me give us a little bit of room. Oops, hold on a second, guys. Paste it in here, and now it's not wanting to do it. Let's do this one more time. Okay, just want to give us some extra room in there. Okay, sorry about that. So now that we have our 20 figures, again, we'll have to figure out our n, our standard deviation, our s, e, or standard error. And then we also want to figure out for the FPC that finite population correction. So we need to find out the population n, the small n for our sample, then our population sample minus our population total versus our sample total, and then our population minus 1. So those are all the things we're going to figure out. So this we know is going to be 20 countries, 'cause it says in the questions. Here we'll do our standard deviation again for sample, and then we can select all 20 of our figures. And so that gives us our standard deviation. So I'm also going to put one blank in here. So this is going to be the standard error with the finite population correction added to it. So just so you can see that. So for this one, again, we calculated as our standard deviation divided by the square root of our sample, and that gives us 16.709. Now to calculate our finite population correction, first we got to grab our the population, which is 149, and again, that's just what I looked it up ahead of time and wrote it down. Our sample size is 20, therefore this is going to be population minus sample, and this is going to be n minus 1, so we're going to do 149. Sorry, let's do the actual cells, so n minus 1. So then to come up with our figure for our finite population, all it is this number right here, the 129 divided by the 148. So we can just quickly grab that, divided by, oops, I'm sorry about that, that figure. And then that gives us this percentage right here that's kind of our corrective figure. So it's just going to kind of take pretty much 87% of this number, the 16.7 number. So if we just do our standard error, and we're going to multiply this by this number, and that will give us, I'll highlight it in red, bold it. So that's going to give us the number. If we use the finite population correction, if we don't, it would give us this 16.7098 and so on. Okay, so that is B. And then for C, this is going into the blood pressure tab, and they're looking for a sample of 42. So we'll just do this again. Select, hopefully this one isn't too long. Oh, there it is. Okay, so we have all of our cells selected, and then we'll do our formula for RAN, and then our Control Shift Enter, and then we copy all the cells, and then we paste the formulas on top of itself. And then from there, we're going to do the sorting again. So we'll sort from smallest to largest. And now we have all of our information, so we can select 42 samples this time. So there's 42. We'll copy those over into our tab. And let's see, here we go. So now I think we're just having to kind of do simply just the population size, the standard deviation, and the standard error of the mean. So let me just bring these over here. And so we know n is 42. Standard deviation, we do the standard deviation of our sample. We can select all that. And what happened to our standard deviation? Oh, that was weird. So our standard deviation is roughly 2.45, so on. And then we'll do our formula again. So standard deviation divided by the square root of our sample. And that will give us our answer right here. So let me write that. So that's it for 6.3, question 2.